Have you wondered how to use L'Hopital's rule when dealing with a calculus problem? Well, I'm here to help you today with High Peak Education. What's going on, everybody? Hope you are having a wonderful day and would like to go over this problem here where we are taking the limit as x approaches 0 of the cosecant of x minus the cotangent of x. Now, the idea is that if you plug in 0, the idea is that the cosecant of x is 1 over 0. So that's like infinity. And then this is sort of like infinity. And then the cotangent of x, well, it's also like 1 over 0. So that's minus infinity. So this is what we call indeterminate form. We don't really know if this ends up being 0 or if one infinity is larger than the other, etc. So instead, we should do the following. We should change the form. So we know that the cosecant of x from the reciprocal functions is 1 over the sine of x. And we also know that the cotangent of x by trigonometric identities is the cosine of x over the sine of x. Now, since both of these fractions already have a common denominator, we can combine them into a single fraction and express that as 1 minus cosine x divided by sine x. Notice if we now plug in 0, because that's really what a limit is. You're plugging in an x value to get some y value. We have 1 minus 1, because the cosine of 0 is 1 from the unit circle, over the sine of 0, and that's 0 over 0, which is another form of indeterminate form. But whenever you have this 0 over 0 indeterminate form, you can use what we call L'Hopital's rule. So a lot of times we just write LH with an arrow. And what we're performing is we're performing the derivative with respect to x of the numerator divided by the derivative with respect to x of the denominator. So that process, I'll just write LH for L'Hopital's rule, is the derivative of this numerator with respect to x. Well, the derivative of a constant is 0. And the derivative of cosine x is negative sine x. But there's also a minus sign here. So I think we'll get just a positive sine x. And indeed, the derivative of sine x is cosine x. Now, with that in mind, we can plug the value in. So we have the sine of 0, because that's the limit value, over the cosine of 0. Well, the sine of 0 is 0. And the cosine of 0 is 1. So this limit is indeed 0. Okay, so this ends the problem. Thank you very much for watching. Please smash that like button if you enjoyed this content. And thank you for watching High Peak Education.